here, right in the distance there. We found it. We're at Hormond Hill near, I think I'm near Shrewsbury, and it's just caught up in the tree. We're going to have to try and get it out of the tree, but we found it. We found it. Wow. There's our balloon and the payload, all safe and sound. It's right up there. That's the only problem now, is we've got to get it down. So we've found our payload, but because it's caught up in the tree, we've had to send Stuart up in the tree to try and get it out the tree. And down the bottom here, I've got Alan. He's also trying to battle to get it out the tree. We obviously got to be careful with the tree and careful with the payload and all the instruments we've got on it, all the trackers and everything. It's slowly coming out of the tree now. This is real teamwork to try and get our payload back. Nearly there. I don't know if I can come over and help a little bit. Way! We've got it! Fantastic! Wow, that has been, how many miles up did it go in the end?
We think about 28 kilometres, but until we look at all the data, we won't know for sure.
Wow, so this went up, we think, about 28 kilometres. So about 28 kilometres up in the sky to the edge of space. That's where our payload has gone this morning. You saw it launching from the Welshpool site. And hopefully in here is all our science experiments. I can't wait to open this up. And we're now going out to find another balloon, the other one. They've actually landed quite close together. We set them off together. They had the same amount of helium inside the balloons. They had the same weight in the payload as well. And it looks like they've landed quite close together. So we're using what 3 words? We're using those trackers to help us. And we think the other balloon is just up here. We've got our next balloon to find. And it's somewhere through here. Simon's gone ahead of us because he's got the tracking app on his phone, so he's gone ahead of us. And if I shout, we might be able to hear him. Let's see if we can hear him. Simon! He's right over here, so we'll keep going. It's a little bit of a trek, this is. I'm on a real treasure hunt now. Hello! Hello, I can see you now. Right, we've nearly found Simon. He's located the second balloon in our forest. Don't tell me it's in a tree. We found our second balloon. It's just up in the tree here. That was quite a trek to go get this one. Oh look, the payload is right here and it's on the ground this time. It'll be a lot easier. We've got our polystyrene ball with all that scientific equipment inside it, nicely protected. There is our ping pong balls, and up the top there, caught very nicely in this tree, is our parachute and our balloon. And we can't leave it there. We're going to have to get it back because it's really important we don't leave any litter anywhere. So I wonder if I can do it by pulling. Let's see if I can. Here it comes. Hooray! All the way down. There! And we've got it! We found our second space balloon payload. Look at that, we've got it. That was quite a trek. Well, we've got our payloads back, and we obviously want to have a good look at what has gone on with our experiment that we sent into space. And with me now is Alan. Hi, Alan.
Hi, Sally.
Now, we met you earlier on when you were predicting where our balloons were going to go, and you got it pretty spot on, really.
We did. Yeah, we were really pleased with how close they were. Of course, virtually everything was the same in both, so we expected it, but you never know. Anything can happen once we release those balloons.
Oh, it's amazing. And they were, I mean, we released them quite close together and they landed quite close together. I look like I've been through a hedge backwards because I literally have been battling. You nearly had to go up a tree as well, so it was quite something to get them back. But right, now here is our ping pong balls. Should we start at this end?
We should, let's do that.
Right, so this one was the bubble wrap. And I'm wondering whether it's changed or not. Should we have a look
it's
and
gone
see?
up, it's been exposed to a lot of cold, and of course the pressure around it has changed.
Right, so
And
it's popped.
It's popped, of course, because the pressure around it was lower. Of course, all the air, just like the helium balloon really, it was pushing out, all the air inside wanted to push out, and yeah, it's popped the bubble wrap.
So that has definitely
Great.
changed. We can really see that, very visually changed. Right, now we have our seed. So this was our, I think it's our broad bean seed actually. Let's have a look. Going to open that one up. Let's see if we can get it out. Okay, right. It doesn't look as though it's changed to me.
and probably we wouldn't have expected it to have changed. I don't think, if we thought about it, the cold might have affected it, maybe, possibly, if it went really cold. But the atmospheric pressure hasn't affected it externally. But of course, one of the reasons why we often put a seed in is to see what happens, not just of that seed, but the seed that we didn't send up with it. So it's like its sister seed that we've kept down on the earth, and we're going to plant them and compare them.
Right.
So we can compare what happens to a seed that goes into space and is exposed to cold and a change in pressure, and what happens to a seed that has just stayed on the ground. And we'll plant them and see if they grow differently.
So we can compare if them and see if there's any change at all. So that's our seed, right? We'll put that one back. Let's have a look. Ah, this is my personal favourite, this one. This is the chocolate one. So I'm going to open it up and see what our chocolate's like. Let's try and get our chocolate out of here. Okay, it has changed slightly, actually. Yes, it has. It's got a little bit of sort of grey. That's the fat that's come out, isn't it?
Yes, because of the cold, the fats have actually risen to the surface. And actually, if you've ever put chocolate into a freezer,
oh, it's gone white, hasn't it?
It goes white, doesn't it? And it's that same thing. Now, the question we've got is, you know, at the moment, that's a change. Could it be reversed back? We'd probably have to melt it again and reprocess it. But at the moment, it looks like that's kind of a change that we can't. It hasn't just changed back. Now it's back on Earth. So you could say that's an irreversible change.
Yeah, that's what I was going to say. You're going to have to do quite something to get that back. Right, we'll put that in there. Okay. So we've got something that's completely changed. Well, two things. That's changed a bit. That's not changed, obviously, but could be more. Right. This is our marshmallow. I did enjoy the marshmallows. Let's see what this one's like. Let's open it up. Oh, now that again has changed just slightly. What do you think?
It has slightly, and of course, this is a good example. I think when we saw in the lesson, when Dave did the experiment of the balloon expanding, I think if you remember us watching that, of course, as soon as Dave put the air back into the vacuum jar, the balloon went back into its original shape. Remember, it expanded and then back into its shape. And I think probably that's happened. If you put this into a vacuum jar and you took all the air out, it would expand. But of course, as soon as you put the air back in, the pressure pushes it all back into its original shape. But as you can see,
wrinkly,
it's slightly
isn't it?
wrinkly. Yeah, I think it's just been put, maybe some of the air that's already naturally inside it has escaped. So it's lost its shape a little bit, really.
Yes, it was supposed to be a rabbit. It doesn't look much like a rabbit now.
Not really a rabbit. So it has changed.
So we've had a change there as well. Yeah. Okay, we've got two more to go. So we put our marshmallow back in there. There we are. Right, two more to go. This is our popcorn. So I'm really interested to see whether our popcorn has popped. So let's have a look. Let's open it up. And the answer is no, it hasn't.
No, it hasn't. No. And this is something a lot of, when we work with schools and they design these experiments, often they want to see popcorn. Of course, everybody loves popcorn, and they think it will actually pop. It's probably the heat that's going to make the biggest change. And of course, where we sent the balloon today, there was very little heat. The change in pressure doesn't really change because there's not a lot of air inside that popcorn. As you can see, it's a very solid piece of material, whereas compared to the marshmallow, which had air inside it. So the change in air pressure didn't change the popcorn as much. There might be some changes. We could also, just like the...
I was going to say, can we grow them?
We could probably try and grow them as well, couldn't we? Like the broad bean, we could try and grow them with the ones that we've got back in at base and see if there's a difference.
Right, okay, so no obvious visual difference there. So put that one there. And then our very, very last one, so 1, 2, 3, 4, 5, 6. Our very last one is our rubber bands. So let's see if there's any change in these. Okay, here we go. I'm going to very carefully bring it out. Right.
No.
No, it doesn't look
too much. And of course, one of the reasons why we didn't send it up expecting that there would be a lot of external change, but what you've just done there is perfect, because that's exactly what we were looking for. The reason we sent that rubber band up was we were interested, does going up into a colder atmosphere, change in air pressure, does that change its stretchiness? So how much you can stretch it. And of course, how do we know that? Because we've got one at base. Once we get back to base, we've got another one exactly the same. and we can test them both and see how far we can stretch it before they break. Both the same, then there's no real change. Could be that one snaps before another.
Right, okay, so you can compare it then if
So
you've got
we
one
compare it, yeah.
in control. There we are, we'll put that in there. There we are, right. Well, we have had actually quite a lot of change in some of these objects, haven't we? Some changes are almost hidden, we don't know yet until we do more experiments. You can't always get it right in the first experiment, can you? That's why we do lots and repeat our experiments to try and get those results.
Absolutely.
That's fantastic. Brilliant. Wow, it's been a long day, hasn't it?
It has, and we've done some really good science today, and you can also find as well, hopefully we'll get the data from our trackers as well.
Yes.
And we can look at that as well. There'll also be something on the website where if you want to, you can see if you can work out yourself how high the balloon went, the ascent rate as well, just by using some of the data from here, putting it into a spreadsheet and doing some maths. So there'll be another activity on the website, as well as the worksheet that you've probably already possibly filled in.
Hopefully you have. Hopefully you have.
Brilliant.
Well, it's been a really busy day. It's been great fun. We've had a lot of excitement today. You have learnt lots. We've learnt lots. It's been amazing. We didn't know if it was going to go perfectly today, and I think it's gone pretty perfectly.
It's been great, yeah.
It's been fantastic. So don't forget to tune in and follow us and do more live lessons with us. Use that hashtag STEMLive and put those Twitter pictures up. We'd love to see them. We really would. And thank you so much for joining us today. Look forward to seeing you again soon.